This section is 13.1. It's over factoring monomials and polynomials. So let me just take a quick minute to talk to you about what factors are. You'll remember this from middle school. Like if I take 24, the factors of 24 are 1 times 24, 2 times 12. I can replace the 12 with 6 times 2, and I can replace the 6 with 2 times 3. So these are all the factors of 24. So if I take a look at the factors of 30, I can do the same thing. 2 and 15, and I can replace the 15 with 3 and 5. So 2, 3, and 5. So these are all the factors of 30. So if I wanted to talk about a greatest common factor, a lot of times we call it a GCF. The greatest common factor, greatest meaning the biggest, common meaning that they both share it, and factor meaning the things that I've circled. So I can see that they do share a 1. They share the number 2 a couple of different times, and they share the number 3. But they don't share a 5. There's only a 5 in the 30, and they don't share a 6. There's only a 6 in the 24. So the greatest common factor would then be 3. You can double check. This isn't double checking you have the right greatest common factor, but if 3 is truly a factor, you should be able to divide it into both of these numbers evenly. So 3 goes into 24 8 times, 3 goes into 30 10 times. But that doesn't guarantee that it's the greatest one, because I can divide 2 into there and I can divide 1 into there. That's just a way to guarantee that you have a factor. But you want to be looking for the greatest one. Okay? So let me add some variables in there. If I said I had 24 a to the 4th and I had 30 a squared, your greatest common factor, you can do it in 2 parts. You can look at the numbers first. So we already know that the greatest common factor between 24 and 30 is 3. The greatest common factor between a to the 4th and a squared, let's take a look at a's. So a to the 4th, let me do it over here because I'm running out of room. A to the 4th is a times a times a times a. A squared is a times a. So what they share, or what they have in common, is 2 sets of a's. So a squared. And I can also double check it like I did with a 3 right here. A to the 4th divided by a squared, that goes into that exactly 2 times. And I can do the same with a squared going into a squared equaling 1. So 3a squared is the greatest common factor. So here's another one. 10x plus 6. So it's a binomial. So you're looking for a GCF, or a greatest common factor, a number that goes into 6 and 10 evenly, but it's got to be the biggest number. So like they're both even numbers, so I know 2 goes into them. I always look at the smaller number and think about the factors of it, and then just check the bigger number. Like the only things that go into 6 is 1 and 6 won't go into 10 evenly. And then 2 and 3. And 3 won't go into 10, but 2 does. So I know that the GCF is 2. So I'm going to put the GCF out front, and I'm going to divide each monomial by 2. So I don't usually write this part in there. I usually do this part in my head, but I'm going to write it in here. Some people just like to do that, write it down like that. So I divide it by 2. And 10x divided by 2 is 5x, and 6 divided by 2 is 3. So I get 2 times 5x times the quantity 5x plus 3. You can check yourself by multiplying back again. If you're not going to do it physically, it's really good to do it in your head, just to keeps your knowledge of the multiplying monomials fresh, plus it helps you understand the distributive property backwards. So 2 times 5x, you learned that in a couple sections, I think last section or section before. So 2 times 5 is 10, and then the x is with that, because 2 times 5x. Then 2 times 3 is 6. And then you look to see that this and the original are the same. If they're the same, then you know you did it right. You don't have to do that for every one. The actual answer to the problem is right here. So you learned distributive property in an earlier section, and you're learning how to undistribute. So like unsimplify. So this right here is simplified, but your final answer is not. So factoring is like undoing the distributive property. So let's try another one. Let's see. Let's put some variables in there. 15x squared plus 10x. So remember, you're looking for a GCF between both of them. So if we take a look at just the numbers, 15 and 10. 10's a smaller one, and the things that go into 10, you always want to look to see if 10 will go into the other number. So 10 won't go into 15, because if it did, that would be the biggest one, the greatest. But it doesn't. So 2 and 5 go into 10. Well, 5 goes into 15, so that's got to be the GCF. So I'm going to put a 5 up here. Now looking at the variables, just looking at the variables, I have x squared and I have x. So they share only one x. So their common is 1x. So I'm going to put 5x on the outside. I'm going to move this down farther. I'm going to put 5x on the outside. And remember, you can be doing this other part in your head, but I'm going to show it because it's notes. So I'm going to divide by 5x. And I'm going to divide this one by 5x. So 15 divided by 5 is 3. So I'm going to put a 3 here. And x squared divided by x, remember that means x squared looks like that and x looks like that. So those are going to cancel, it's going to leave an x. So I'm going to put an x here. So now I can do the second part of the binomial. 10 divided by 5 is 2. I'm also going to bring that plus down. And then x divided by x, those are gone. Because they equal 1, and 1 times 2 is 2. It kind of got messy just because I'm showing you kind of what's going in my mind, what I'm doing in my mind. You don't have to do all that circling in that, I'm just showing you that. So here is your final answer. One thing you want to look for is inside here, if there's a common number inside there, a GCF inside, it means the number on the outside was not the real GCF. It was probably a common factor, but it wasn't the greatest. So like if there would have been a 3x plus 2x in the center, I would have known I screwed up. Okay? It's just something to think about. So 6y cubed minus 2y squared. You might not want to copy this other part. Let me show you what it looks like if you screw up. So let's say you thought it was 2y. You thought the common factor was 2y. So I divide the first monomial by 2y. So 6 divided by 2 is 3, and y cubed divided by y is y squared. And I go and divide the second part of the binomial by 2y. So I bring the subtraction sign down, and 2 divided by 2 is 1, which I don't need that 1, and y squared divided by y is y. Okay? Let's say I thought that was the end. But look here. Inside these parentheses, there's still a common factor. And so that tells me I didn't pull enough y's out. So now I can go back. And I can go, okay, well, I should have pulled more y's out. So the GCF must be 2y squared. So I divide the first one by 2y squared, I get 3y. I divide the second one by 2y squared, and I get 1 whole. 1 whole because 2y squared divided by 2y squared. The 2's cancel and make 1 whole. Remember, it doesn't make 0, it makes 1. And then y squared, whoops, divided by y squared makes 1 whole. So it doesn't disappear and make 0. You got to have that placeholder, that 1. So then my final answer is here. Okay, what if it's a trinomial? So let's get a little bit harder. Oh yeah, that's not good. Have 2 variables. Okay, how about x? I think it had z in the book, and I hate doing z because it looks like my 2's. Minus 6x. Okay, a common factor between those. If I look at all the whole numbers, 6, 9, and 3. I know that 3 goes into them all. And if I look at all the variables, they all share 1x. A trick on variables is you look for the lowest degree, and that's your common factor. So 3x out front. So again, I'm going to divide these all by 3x. I'm going to go ahead and show that work in there. So I divide this by 3x, and I get 1, because the 3 divided by 3, but x cubed divided by x is x squared. And I divide this by 3x. 9 divided by 3 is 3. X squared divided by x is x. And then remember, this is a subtraction sign, so I'm going to be careful and pull that sign down. And divide by 3x. 6 divided by 3 is 2. And the x's cancel. Okay, the next one, let's do another trinomial. If you want to pause this, or no, let's do a binomial. If you want to pause this and try this on your own, you could do that and then just check it afterwards. Okay, a common factor between those two, between 2 and 4 is 2. Between x squared and x is x. And this one shares a y squared, or they share y squared and y cubed, so y squared is common between them. I divide the first one by the greatest common factor, 2xy squared, and I get an x. And the second part of the binomial, 4 divided by 2 is 2. The x's cancel, and there's a y left over. And I'm going through a lot of these just so you get the hang of it. You don't have to do every one of these, but I'm going to get to factoring by grouping, and you want to make sure if you're going to forward through these, you stop there. So on this one, on any of these, you can pause it and try it yourself. I'm going to do 3 more that are similar to this. So common factor is 3x. I divide this one by 3x, and I get 3x, because x squared divided by x leaves an x. And if I divide this one by 3x, I get a 2. The next one, and I'm just taking these right out of the textbook. The textbook kind of had a weird way of showing just a weird pacing on this, so I kind of just did my own thing on this video. But I'm taking the examples out of there. So the common factor is 4x squared. That leaves me with x squared plus 2. And the last one in this section, 8a squared b cubed minus 16a cubed b squared. So if you have a problem with dyslexia, this problem can be confusing. They're too much alike, but I pull an 8 out. Between the a's, they share 2 of them, and between the b's, they share 2 of them. Oops, forgot what I was doing there. And then I divide the binomial by the greatest common factor, and I get b minus 2a. The next section is factoring by grouping. Factoring by grouping happens when you have a 4-term polynomial, and I'm going to start like the textbook did with having it half factored for you. So this would be like you're halfway through the problem. I'll show you how to get the first part of the problem afterwards. But if your problem was written like this, you were to this point, you can see that 5x is multiplied by what's in this parenthesis, and then 6 is multiplied by what's in this parenthesis, and they're added together. So if that happens, then you can rewrite it as 5x plus 6 times x plus 3. The reason you can do that, and this would be your final answer, okay? The reason you can do that is think about going backwards. You're going to multiply 5x times both of these terms. You know, when you FOIL, you go the 5x times a 5 and the 5x times a 3. Then you're going to multiply the 6 times both of those terms. And so in the last section where we multiplied binomials times binomials, and they called it FOILing, that has to do with that. Okay, so let me give you another example. And you might want to pause it and try this one on your own. This only works when what's in the parentheses is exactly the same. That's the only time it works. So since the x squared and the minus 4x are both multiplied by the same binomial, I can write them separately. And then just multiply them once by that binomial. And that's it. So let me show you what it looks like from the start of the problem. So that would be like when you're halfway through the problem. If I have 2x cubed minus 4x squared plus 3x minus 6. Let's say you had this polynomial and it has 4 terms. Then factoring by grouping is a way of how to deal with polynomials that have 4 terms. It works on 4 terms. So imagine grouping the first 2 together and then the second 2 together. If I did that, then I could look in here and say, well, I can pull out something. I can factor something out. Okay. So what's common between 2x cubed and 4x squared is 2x. And then I can write what's left, which would be x squared minus 2, whoops, back up. I can't have 2 x's in there, right? I know I messed up. So there must be x squared that's in common. There we go. So let me erase this part. It's a good way to show you how you know if you're messed up. So that would leave me with x minus 2. Now if I do the same thing over here, and I say what's common between these, and I bring that plus down, what's common between those is 3. And then if I pull a 3 out, if I factor a 3 out and I divide those both by 3, I get x minus 2. So now I'm to that point where I just showed you earlier, where you have the parentheses that match, where you have 2x squared times this quantity inside the parenthesis, and you have 3 times this quantity inside the parenthesis. And so then you're able to write it like this, 2x squared plus 3, and x minus 2, and then you're finished. If I lost you at this step, what I did, let me change color so that you can see it. What I was doing is I was looking inside here and I was saying, well, they both have a 2x in common, so I can divide them by, or 2x squared. So I can divide them by 2x squared, just like we did before. And I looked inside the second set in here, and I said those have a 3 in common, so I divided this by 3 and I divided this by 3. That's how I got that second step. Okay, so let's try another one. Okay, so the next problem is 3y cubed minus y squared minus 9y plus 3. This one's different because it has a minus between these. So when I group these, let me change color. When I group these two together, when I go to group these two, I really, it's a lot easier if you make this a plus and let that minus sign go with that 9. That way when we look inside this group here, we might have to factor out a negative or a positive, and it's just a lot easier to think about. Okay, so you don't have to, but it ends up being easier. The common factor in the first binomial is y squared, so I'm going to pull that out. So when I say pull that out, I mean divide each of them by y squared. That leaves me with 3y minus 1. And I want this other factor to be 3y minus 1. So when I look inside here, you kind of got to think ahead. If I want this to be 3y minus 1, I know I've got to factor out a 3, but I want this part to be minus. So that means I have to factor out a negative 3. If I factor out a negative 3, if I divide this by negative 3, negative 9 divided by negative 3 makes a positive 3y. And that's what I wanted it to be. I have to have it match that first binomial. So it's kind of tricky. You have to think about if you're going to factor out a negative or a positive to make that match. And then I'm going to get minus 1. So now I can just rewrite this part. Becomes really quick when you get the hang of it. After you do a couple of these, they're not so bad. The first couple that you do, you feel like, oh my gosh, they take so long. But once you do a couple, they're not bad. Okay, so the last one in this section, you might want to try it by yourself. Ugh, it's z's. Ugh. Plus 4 z squared minus 5z minus 20. So again, you've got that minus in there, so give that a shot. Okay, so I'm going to, because there's 4 terms, I'm going to use my grouping. Remember, this works when there's 4 terms. But I'm going to change that to a negative 5. So I'm going to pull out z squared, and it's going to leave me with z plus 4. So I want this second set to be z plus 4. So that kind of helps me know what the factor to pull out is. The first one is negative 5z, and I want it to be positive z. So I'm going to divide it or pull out a negative 5. And that's going to leave me with z minus, or plus 4, because negative 20 divided by negative 5. So if I divide this by negative 5. I'm thinking of this as negative 20 instead of minus 20. It's kind of that bubble thing that I showed you early on. So at that point, as long as these match exactly, then I can go ahead and write my final answer. Okay, the next one has to do with polynomials that have 4 terms, but the ones that I've given you so far have never had anything in common. So now I'm going to give you a polynomial where all of a sudden they have something in common. So if you look back at the old ones, they never had anything that was a greatest common factor amongst all of them. And that's what you really want to look for first. if you get messed up on regrouping and you regroup and you're like, oh, there's still a common factor between those parentheses, then that means that there was a GCF that you should have pulled out beforehand. So if I look at all these, and this part is as hard as it gets, okay? So if I look at all of these, I can see that they all have a 3 in common. So I'm going to take a 3 out to start with, and I'm going to rewrite the rest. So I'm going to get 2x cubed minus 4x squared minus x plus 2. Okay, now this 3 that I took out, I'm going to leave it out here, and I'm going to write it a bunch of times so I don't forget it in the answer. It stays there, and now I'm not going to focus on that 3 anymore. I'm not even going to look at it. Okay, so now I'm going to go and look just inside here. I've got 4 terms, so I know I have to regroup. I know that between the groups it's a subtraction, so I'm going to change that to addition and add a negative to the x. Now I'm going to pull out common factors. So the first binomial has a 2x squared in common. So I'm going to pull that out, and that's going to leave me with x minus 2. The second set, I want it to be x minus 2. Right now, it's negative x plus 2. So it's almost there. All the variables and the numbers look the same, but the signs are all opposite. So that means I have to pull out a negative 1. Because if you divide negative 1 by things, then signs flip. Negative divided by negative is a positive, and a positive divided by negative is a negative. So that's what's going to give me that x minus 2. So now, if I rewrite just the yellow part, I have 2x squared minus 1 times x minus 2. Because remember, these were exactly the same. That's what I wanted. So now, this part is now my final answer. If I wanted to check it, I could I could do it a couple ways. I could multiply these two binomials together and then take that answer and multiply it all by 3. Or I could multiply 3 times one of the binomials and then multiply the two binomials together. That would be a long time to check, but if you were on a test or something and you had extra time at the end, and you weren't sure if the problem was right, you could go back and multiply everything back together and see if you get the original problem. So, like I said, these are the hardest kind because you forget. I see the students forget to find that GCF first. So the first thing I say when they say, I don't get that problem, I got it wrong, so did you pull out a GCF? Okay, so 2x to the 5th minus 8x to the 4th plus 6x cubed minus 24x squared. So the first thing you're looking for is that GCF. So remember, GCF, GCF, GCF. So a GCF between all of those is 2. And then it looks like there's a GCF in the x's too. So they all share x's and they share an x squared because the negative 24x squared has the lowest degree, so you know that that's the amount that they have in common. So again, I'm going to do this middle part, and I'm going to forget about this 2x squared. I usually write it a couple times going down the page just because I know that I am horrible at details and I will drop that off, especially if I'm on a test or something and I'm nervous. So I'm going to factor out that 2x squared. I'm going to get x cubed minus 4x squared plus 3x minus 12. And now I'm going to regroup because there are 4 terms. So I'm going to group these two together and these two, and that's nice. There's a plus in the middle, so I don't have to worry about that. I'm going to pull out an x out of the first one, actually an x squared. It's going to leave me with x minus 4. And out of that second one, I'm going to pull out a 3, and it's going to leave me with x minus 4. So I know I did okay because I came out with the same binomials.